at the very high level into two parts: supervised and unsupervised learning. Right? I'll give each a brief in the later slides. But just to know, supervised is when you supervise your machine, right? It's the word's meaning itself. You tell the machine that for this input, I should get this output, right? So I give an input, I expect this output, but the machine gives me another output, right? So I get the difference between the machine's output and my expected output, right? And I get the difference, and I have to minimize that difference, right? So that machine can predict much better. So that's supervised learning. In unsupervised learning, you just give the machine some data set and let the machine decide what kind of similarities that the data set have with each other. So we don't tell them that for these inputs I need these outputs. We don't know what the output will look like, right? The machine decides how the inputs, how your data set should be clustered. So in supervised learning we have classification and regression. So we in the later slides I'll explain this in a bit deep. And in classification, I think all of you know about artificial neural networks, LBQs, support vector machines, and hidden Markov models. Just forget about the names. Don't forget. Just keep in mind that these kind of models are there. So whenever you need a machine learning model to your project, you can search out these ones and see if these models suit your project better, right? Which one? So in regression, we have linear and logistic regression. So classification and regression are broken into two parts because the data set is different. In classification, we have a discrete data set, and in regression, we have a continuous data set. So at first, I don't know what discrete and continuous is, right? I hope most of you guys are there as well. So can someone tell me what a discrete data set is? Yeah. So in a discrete data set, in a discrete output, the number of outputs are a defined number of sets, right? But in a continuous one, you can't define the outputs to a certain number, right? It's continuous. So for an example, let's say how your age changes with time, right? Time and age goes like this, right? When time increases, the age increases as well, right? So for each amount of time, you have a specific age, right? So it's continuous, it's not discrete. There is no defined number of values, right? So let's see more examples in the next slide. So unsupervised learning is basically clustering your data. So there are some clustering algorithms, k-means, self-organizing maps, neural gas, ASR mining, and self-organizing maps are not that much popular. Just take a look at the research papers that are on there. So okay, so let's go into unsupervised learning first. So do you guys have any questions on the stuff that we brought over right? Any questions? Okay, so well understood. So unsupervised learning. Right, so as I mentioned before, we have no idea about the data set that we are getting. Right? So we let the machine decide the relationship between the variables of the data set. And doing that analysis, the machine clusters similar data into groups. Right? We look at an example and try to understand. So, given these types of animals, right, I'm not going to tell you how you are going to group them, right? So, how would you group them if I give you the features of this animal, right? So I'm going to give you number of legs, their body color, do they have feathers, is it a bird, is it a mammal? Those are the features of your data set, right? Your data set is not horse, the chicken, the goat, the cow. Those are not your data, right? Your data is the features of it. If you take the horse, it's a mammal. It has it's brown color, right? And it has 4 legs, stuff like that. So those features are your inputs to your model, right? So based on those inputs, the machine can group similar animals into similar groups, right? So if we get the features like they have 4 legs and mammals, right? So if we give the machine only those 2 features, the machine can cluster similar animals into similar groups, right? So we are not telling them which animal is which, but the machine cluster by themselves, so by itself. So if we just tell them have feathers and is white color, have feathers and is white color, so it can cluster it like that. So there are a number of features to consider. You can cluster these animals in many ways, right? It only depends on what the features that you give to your model. So based on that, the machine will cluster. So you can try this out. You can give many features. You don't have to code these. You just give many features to your model, right? So you can get similar groups of animals into similar categories, right? So that way, that's how unsupervised learning works. And yeah, so hair color, number of legs, height and weight. If you give these as features, if certain animals have certain range of ages, heights and weights, the machine will cluster them in a single group. Right. So let's say our features, we only have 2 features, right? Let's say we have number of legs here and is a mammal over there, right? So is a mammal is true, false, just to disregard it, and number of legs goes like this, right? So if we plot these your animals, let's say is a mammal, yes, is here, and is a mammal, not is there, right? So number of legs 2 is here, and is a mammal, yes, is here. So 2-legged mammals will go into this cluster, right? And if 4 legs are here, and mammals are here, right? So 4-legged mammals will go into another cluster, right? So likewise, based on your data set and your features, the clusters will be formed in your machine, and what you need to find is the boundary between these clusters, right? How these clusters are divided with each other. So that's what your machine learning model does. And sometimes you get outliers, right? In your data set, there are some data that can't be classified into any cluster, right? Those are called outliers. These outliers are used in fraud transaction detection in banks, right? Say if you have a similar pattern of withdrawing your money, and sometimes you withdraw a lot of money that goes out of your pattern, it's an outlier, right? That's how they recognize outliers, and they send you a message saying that this is out of your normal withdrawal pattern, so there's an outlier. Right? So that's how machine learning models work in financial fraud transaction handling. Right. So this is a walkthrough on how K-means clustering is an algorithm that is used to divide the clusters in an unsupervised learning model, right? So let's say you plot your data set. You know how to plot right now, right? So you, based on two features, you plot your data set, right? So at a glance, if you see these things, two things, you clearly see that there is a boundary, right? But we need the machine to figure the boundary out itself. So how do you do that, right? So what K-means clustering is, does that. It takes two arbitrary points somewhere in the data set, right? Some XY coordinates somewhere in your data set, right? You get those two coordinates and you find the line that goes right in the middle of those two points, right? That means the distance from this point to this line and the distance between this point and this line is at its minimum, right? So it's right in the middle. So now what we do is, so we have two groups based on the line, and we calculate the distance between each point to this midpoint, right? So distance between from this point to this point, this point to this point, this point to these points, right? And we find that there are some points that are really far away, right? So this is not a good prediction, right? This is not a good division. This is not the minimum distance between the point and the midpoint. So what we do is we arbitrarily take another 2 points, right? So this time the point is here and the point is there. Other point is there. So we draw another line between them and we calculate distance from each point. Now we get a good cost. Our error is a little bit minimized, but it can improve much more. So we get another 2 points. So what we do is when we divide this by this line, right? So we move this point to some midpoint here and here, and even in there, what we do is we move the point to the middle. So we move this point to the middle of this cluster, and we move this point to the middle of this cluster, right? So likewise, we move this point to the middle of this cluster and move the red point to the middle of its cluster, right? So we draw another line between them and we calculate the distance again, right? So now we find that the cost is a lot much better, and we again move it to the middle. There is no other middle right now, right? So we don't have any other middle to find out because we have the cost at its minimum. So that's how the K-means clustering algorithm works. After you find the best line that fits your model, when a new point comes in, you can classify whether it's a red class or a blue class, right? So that's how unsupervised learning clustering works. If you don't get this, that's okay, right? Just I have to tell you guys that there are some things like that, right? So you can go home and check this out more. None of this stuff that I'm telling today is going to go into your head, right? You just have to know that these kind of stuff are there in the world. Go home and check it out if you're interested, right? All of you are not going to be machine learning experts, right? There might be people who hate machine learning. So just know that these kind of stuff are there. Go home if you're interested and check it out. Okay, so your question.
So when a new value is introduced, it will be organized into unstructured clusters. Yeah?
So we only need the line only. So if you have a straight line that goes in some graph, if a new point comes in, you know that point goes in either the left side or the right side of that line, right?
Would the new point cause the clustering to change?
No. If you are doing reinforcement then for every new value, the thing is that you don't know if the outcome of the value, right? It's unsupervised. So if you are reinforcing, if this is your training set, the training is done from here, right? From this point onwards, you do the testing. But if you are training again and again and again, you can adjust the line. So this is a good question. Questions here? These are the only figures I have to stop at some point. Okay. Any other questions? So let's say that you have certain types of people that you can group into two groups, right? So if a new person comes in, based on its features, we can say belongs to this group or that group. Okay? You don't have to do another calculation again. You have a straight line. You just need to figure out whether the point goes on the left side or the right side of the line. So if it goes on the right side, it's a blue. And if it's left side, it's a red blue. Okay. So we are going into supervised learning. So in supervised learning, you have labeled inputs and you have a training process and you have specified specific outputs that you know that these outputs, you know the correct output and the machine predicts its output, and what you have to do is you have to find the difference between the machine's prediction and your actual output and to minimize that cost. So that the cost function, that's something that you have to keep in your head. The cost function is the difference between the expected output, that means the actual output, the true output, and the predicted value of the machine. So you have to minimize that cost, right? Now let's see. So we know that there is a relationship between the input and output, right? So for an example, if you get cancer patients, right? So we can get features of their health conditions, right? Of some past cancer patients. Let's say we have thousands of cancer patients of the past and we have their features. So based on these features, let's say we have two features. Let's say they are blood levels or something like that, right? So we get two features and we know that this person has cancer or not because they are actual data from the past, right? So if the two features is like that, it has a cancer. So based on that, you have thousands of data, and we train the model like that. So if you feed in another data set in the future, so it should predict based on what it has learned from the past. Let's see a more descriptive example. So we already have data set with correct outputs to their inputs, right? So that's the difference in supervised learning. Beforehand we have a data set which has the correct inputs and outputs. So we try to predict outputs for the new data based on the relationship from all data values. So based on the past data values, the correct values, we try to predict a new value if there is a relationship between those two. Right. So classification and regression are two types. Right. So classification is you have discrete classes. So you can divide your data into a defined number of classes. But in regression, you have a continuous data line, right? So given at any point, you can find the output. Let's say this is the x-axis and this is the y-axis, right? So in the y-axis, you have the outputs. In the x-axis, you have the input. So given any input, you can find the output, right? Because you are drawing a line. This line is your model. So in that line, you have for any given input, you can get the output, predict the output, right? So these blue dots that you see are your training input values, right? So the line does not go inside each of them, but it's a more generalized line. There can be some errors, but the prediction probability is generalized that where it can match all the points, right? So we are trying to find the best line that suits every point, that minimizes the error of every point. So the cost function here is the distance between the point and your line, right? So the cost as a whole, the sum of all these distances is the final cost of your model. So you are trying to minimize that cost. So you get the best line that minimizes that cost. Same here, but differently you translate into two classes, 2 or 3 or more classes. So this is a linear classification, just 2 classes. You draw a line and you classify it into 2 sides, right? So at first we had an unsupervised learning algorithm where we try to draw a line and just begin, right? So here we know that the data set here is one group and the other one is the other group. We know beforehand, right? So we tell the machine that we need to find a relationship if we can divide these two into 2 classes, right? So we tell the machine to find the best line between these layers, right? So that's how classification works. Any questions? Yeah.
Classification and K1 learning is quite similar.
Yeah, but yeah.
Because in classification, it knows that what are the 2 data sets, but in K1 learning, it just randomly takes 2 points and
Yeah.
write on.
Yeah, that's right. So in classification, we don't have to tell them to take points in arbitrary, right? You just have to tell them we have 2 classes. Just get the point. You know, you get the middle point of this cluster. Get the middle point of this cluster. So when you get the middle one, you get the best line between, right? Okay. Right. So regression and classification can be used in the same machine learning model. Right. So regression is continuous data, classification is discrete value. So this is a great example how you can divide these two. So you know that there are mobile apps that can predict your age, right? So based on your photo, that app outputs what the machine predict your age is, right? So if it gives a specific value, say 23, 24, 25, 26, right? So it's a continuous value, right? So it's a regression model, right? But if it says that you are old or young, so those are discrete classes, right? So there are no continuous values in that. So that's a classification. So the same learning model, you are giving a photo and you are trying to predict something based on the age. So if you want a specific value of the age, you have to do a regression. But if you are classifying the people whether they are old or young, so that would be a discrete value. So it goes under classification. Any questions? Right. So let's look at we looked at the how regression and classification works. So this is a regression example. So is this true? So in the y-axis you have your free time, right? In the x-axis you have your age. So is this a continuous data set? Is these values continuous? It is, right? The time, the free time and the age. Your age is continuous, right? Every time you age. So if you feed in the age and the free time, your data set would look something like that, right? So if you are 5 years old, you are not going to school and you have a lot of free time for yourself, right? But as you progress in your age, your free time goes down. You cannot you cannot get the value for every single second of your age, right? You just get a small data set. So when you age and when you come to your middle age, you have your free time at its minimum, right? So in our ages, when we have kids and have a family, we have less free time. But as your age progresses and you become old, so you retire and you have more free time. So let's say we have this amount of people, young and old people, we get their free time and we plot it on a graph. So we get plots like that, and so we get an outlier like that, right? So we can get an outlier telling that a very old person has no free time, right? So that's rare, right? So the rare data points are considered as outliers, right? Okay, so what we need to do is we need to find the relationship between these two axes. So given any age, we can predict what their free time is based on, let's say this is for a specific country, right? Let's say for Sri Lanka, the curve, thing looks like, the data points looks like this for the amount of people. So given a new person with their age, we can predict their free time, right? So what we need to do is we need to find a line or a curve that fits these data sets, because it's a regression problem. We are not classifying, right? We are trying to find a data point, right? So if you look at this data set, it looks like a curve, right? So we can fit our line or curve differently. So here, when you give a specific age, it outputs the free time based on this line. Here you have a curve, and here you have something that goes across every data point, right? So what's the best model out of these three? Can someone tell what's the best model that suits our prediction? Second one. Why is that? Yeah. Yeah. What's the wrong between two specific? Yeah. Yeah. So his answer is correct. So his answer is correct. We should not over-classify our model, right? So first one is under-classified. It's nowhere near our data points, right? So the second one is it goes like in the middle of some data point, and it seems like a more generalized one, right? But the third one goes across every data point, right? So this might seem a good model for your training data only, right? Because when you get a new value, you get it somewhere like this, right? But your model doesn't go anywhere near that, right? So let's say if we get a new value, here, there's a big error between your curve and the new value. But if you get this line, the error is much more small. So this is a good model for your training data, right? So you never predict on your training data set, right? You train your model on your training data set, but you never predict things on your training data set. You have a test data set for that. Right. So these are analytic. That's a good one, and that's an awful. So in machine learning, you have to keep in mind that you have to find the more generalized solution for your model, right? Don't overtrain your model. to classify data into classes, but sometimes you can use it to regression as well. But most of the time you use neural networks for classification problems, right? So I told you that what you insert into your model is not the cow, horse, the chicken, right? It's their features. So these X's here are the inputs, right? These inputs are not cow, horse, chicken, goat, right? These inputs are how many legs. One input has many features, right? So if we get a horse, it has X0, X1, X2, X3 features. Legs, color, mammal or not, things like that. So you try to find the best thing. You multiply. So the matrix multiplication, just forget about it. You insert your features and you try to find the best function that outputs what you need. So that's what a neural network does. So I will not go into the deep things on neural networks. I just want you to know that's how neural networks work. So similar to how our brains work, there are neurons, many neurons in the middle. When an input comes into an input neuron, it fires to a neuron in the middle, and it does some calculations, and it outputs to the next layer, and the next layer calculates something and outputs to the other layer, and finally we have an output layer that gives out the prediction. That's how neural network works. Just go ahead and search. I don't know if you people follow courses in Coursera or Udacity or Linda. But if you are interested in machine learning, there are free courses that you can take on Udacity and Coursera. Both of them are free. If you want the certificate, you can pay and get the certificate. The Coursera certificate is a very recognized one. I think it's about 12,000 or 15,000. It's done by Nural, a very reputed professor from Bible Research. If you are interested in learning machine learning from the beginning, I highly recommend you to follow the Coursera one. Right. So going more into artificial neural networks. So just forget about every node in the middle, right? So let's say we have some patients, right? So we are going to classify if we can predict that a new patient has dengue or not, right? So based on the old patients, we can come with a relationship. If there is a relationship between your inputs and the outputs. So given an age, a platelet count, or a white blood cell count, we can come up with a function, mx plus c function, right? That if we can find a relationship between the y and the x, right? So given any x, we can get a y. That's what the y equals mx plus c does, right? So given these features, we get then positive or negative answer. So if the answer is not our expected answer, we get the error, right? And we try to reduce that error. How we reduce that error is by adjusting m and c. In y equals mx plus, is there a so if you have a function like this, right? Y and x are your inputs are x, right? And y is your output. As simple as that. So you can't adjust your y and x, right? If you want to get the best function, what you have to adjust? M and c, right? So we give them the x and we expect a y. but our real y, let's say we start with n equals 1 and c equals 1, and we get a function for x. So we multiply x by 1 and add c1, another one, right? So we let's say y hat, let's say y hat is our predicted output, right? That means we multiply mx plus c, right? So our actual output could be y, and we find the difference between y and y hat. So this is our cost. What we have to do is we have to minimize this cost, right? Our function outputs a y hat, but our actual output is a y. So we find the difference and we try to minimize by adjusting m and c. Now first we added 1 and 1 to both m and c. Now we find another two arbitrary values. Let's say 2 and 4, 6 and 8. We adjust m and c and see if we can get the cost to its minimum, right? So if we can't do better than that, so that's a training model, right? If the cost, if we cannot get the cost, let's say our cost is 0.000125 and the cost doesn't go any below than that, right? So that's the best that we can do for our model. So that's a very simple example. Right. So if that doesn't go into your head, don't take it in right now. Just go home and check it out. Right. So artificial neural networks are the big boss of the machine learning models. So in deep learning, where we have billions of data sets, there are complex image classification models in neural networks called convolutional neural networks. Convolutional neural networks are a really cool concept. There are many YouTube videos on how they work. Just go and check it out. In your Google Photos, in Google Image Search, everywhere they use CNNs, right? So CNN is state-of-the-art machine learning model. So machine learning models are developed, I mean not programmatically, but these are all mathematical models, right? So these are developed by people who are really good at numerical computing and mathematics, right? So they do research and they find that these models are the best ones. What we have to do is, right, we don't need to, if we are doing research, we can try to improve those models, but if it's a state-of-the-art model, we can get the model. All we have to do is, we have to know that this model suits this project, that's it. Right? So we give the input and we get our expected output. So in NLP, natural language processing, which I have C- in university. So in NLP, there are many machine learning models used. In computer games, right? AI is used everywhere in computer games. Google search, Facebook history, and YouTube recommendation. Right. So can someone tell me, you guys have seen recommended videos in YouTube, right? Section, and by time it improves, but we don't know. We don't actually feel it. But I don't know if you felt this, but when you go to YouTube right now, we tend to switch on to the next videos because it seems that it suits us best, right? Not like in the past days, but even in Facebook, right? You tend to scroll more and more. In Instagram, right? It's really hard to even push the explore button in Instagram when you're going in the bus, right? What the images that pops up. So, so in YouTube recommendations, you tend to stay in YouTube much longer, right? So that's the whole point of what they are doing. So can someone tell me how these recommendations would work in a machine learning model? Excuse me?
Past activity.
Yeah, past activity as in what?
So, for example, if you're watching a channel,
Yeah.
you tend to watch like a series, for example, that's part one, part two. You tend to always watch in series, sequence. It tends to figure out that okay, the type person that to watch complete series.
Yeah. So adding to his answer, there is no wrong answer. Your answer is right. And there is no wrong answer. You can put the wrong answer and get a sticker. So adding to his answer, so the YouTube videos have tags on them, right? So it can be riddles, documentaries, songs of certain genres, right? So when you watch those videos, so they have a separate profile for you in YouTube and in Facebook. You know that Facebook has a shadow profile? Anybody know that? Even if you are not registered in Facebook, Facebook has a shadow profile of you. Right? If your friend has uploaded their contacts into Facebook, they have a shadow profile of you. So whenever you log, you think that you are new to Facebook, but you're not. So that was something that Facebook had to answer in the recent scenarios that happened. So in every big site like this, in YouTube, in Facebook, they have a specific profile for you with your statistics in it. You like this kind of music, you like this kind of food, right? You like this kind of movies, right? And based on that, it suggests you friends, food, restaurants, and nowadays you can't search for something, right? It pops up in Facebook, right? So I recently got married, and I was searching for some stuff for my wife, and my newsfeed is full of that. Okay, so supervised and unsupervised learning. Let's try to divide this to much more. So, what do you think the first one is? Is it supervised or unsupervised? Given a set of songs, group them in similar genres. Don't say. Yeah. No, not supervised. That's unsupervised. No answers. So, why did you say it's supervised?
The various set of songs and if there is a genre for that.
Yeah.
There is a
So you are thinking that we tag the genre in the song as a feature. So I was not talking that you think like that. So let's say you give your model, let's say you have a very smart model, right? The model can predict what the genre is, right? So based on that, it can cluster it into similar groups, right? So it gets the feature out of the song. Let's say if it's a fast changing song, so it's an upbeat song, right? So don't think it as a rock or classic or something like that. But if it is an upbeat song and if it's a feature, so all upbeat songs goes into a similar category, right? So your answer is correct if we do it like that. Right? That's good. So you have a set of emails, group them as spam or not spam. Is it supervised or unsupervised? Who thinks it's supervised? Okay, can someone tell me why it's supervised?
Set of emails is limited.
Set of emails is limited.
No, given the set of emails. So
Yeah.
It's like he gives what type it should be moved by.
We should give it. Yeah.
Without any randomly group it as a set of names.
Yeah, I think that's the correct answer, because if we look at emails, right, how we group it as spam and not spam, right? It has learned from the past because advertisers send you spam email, right? So you can't tell that every email is spam, right? Based on the past experience that these are spam emails that people have flagged. People flag emails, right? These are spam, and it goes as a feedback to your email provider, right? So they know that this email is flagged by some users. So based on that past experience, your new emails will be grouped as spam and not spam. So what about the third one? I think we discussed that. Is it supervised or unsupervised? Given a set of cancer patients, learn to predict new patients as they have cancer or not. Supervised. Who thinks it's unsupervised? Okay, that's good. So the fourth one? Again, we are not giving a tag to the food. Right? It's unsupervised. So your machine can get the features out of the food, right? How many vitamins they have, things like that, and it can group automatically into groups, right? You don't have to tell them that these foods have these nutrition. You don't have to do that. You just have to enter what the food actually has. You don't give it an output, right? This nutrition group has this nutrition group. You don't give it as output. You let the machine decide if they fall into similar categories. Good. So every machine learning model can be described into something like this, right? So this is a generalized thing. So you have a training set. Forget about the unsupervised part. So you have a training set. You have a learning algorithm which improves your cost by time, minimize cost, feed it to the learning algorithm. If there's a cost, you minimize it again and again and again and again, and you give out an improved hypothesis, right? What the hypothesis means is your function, mx plus c, right? So you have an improved mx plus c. So given a new data set, it can get a good prediction, right? So do you have any questions in this or the later slides, the previous one? Okay. Right. So I have told you about the cost function earlier. So this is a little bit deep on what a cost function would look like. If you don't understand, just don't try it. Right? Just free your mind when you go home and try to understand this if you really like it. But just for the people who are interested, cost function is the error value between your expected output and your predicted output that you all know, right? So in a linear regression problem, the cost function is the mean squared error. I'll tell that in a cost function vary with the parameters. What are the parameters? Cost function vary with what parameters? M and C, right? So those are the weights that we give them. So what we do is we change M and C, so we get the best line that minimizes our cost. Okay. So you can see a red line here, right? So we have some data points in our graph, and we have a red line drawn here. So from the distance between from each data point to that line is a cost, right? That's an error, right? So every data point together brings out the main cost of our model, right? So the main cost of our model, you don't understand this function, I'll just tell you. So xi is for every I, right? Every I means this one. So I can go from 0 to that data point, right? So for every data point, what's the difference between your line and your data point? Is that x minus fx is your function, right? Fx is your function. Mx plus c is this function, fx. So minus the actual output is this is your function, that means this line, red line. Y is your actual output. It's this data point, right? So we get the difference and we sum the difference between all data points, xi, right? And we get the square value, right? Before we square it, we get the mean of that. That means we divide our cost function from the data points. If we have 10 data points, we divide it by 10 and get the mean, and we get and we square it. Right? The squaring is done because we are going to because for gradient descent, I'll tell that to you in later slides. But just remember that the cost function would look something like that, right? So there are two parameters missing. Can someone tell me what are the two parameters? Two variables missing in that function. We are going to get the mean squared error. What's missing? What's the mean? What's the mean? I should have divided this by the number of data points, right? Otherwise, it's not the mean. It's the squared error. So I have to divide it by the number of data points to get the mean squared error. So it's a generalized error for every point, right? So what we now try to do is to minimize that cost function, right? So this is a very odd question. Does anyone know about derivatives? Avkalian? Okay. So if we plot our cost function, right? I have told you this. Let's say we change our weights, right? And our cost function, we plot it, right? That cost function I showed you. So this one, this function we plot, and we get a curve like this, right? So where is the cost is at its minimum? We train our data set, and we get the cost function like this. So where is at the minimum? Right here, right? This is the minimum value. So in the minimum value, we have a number for n or c, right? This is two-dimensional, so for example, c. If we have three dimensions, we can plot c as well. So for a given n, we get the minimum cost. So that's the best we can do, right? So we get that n and we plug it into our function and we get the correct condition. That's it. That's all we have to do. So we change the value of our n, right, from 0 to some 100 value, and we find that whenever we change this value, this goes up and this goes up to infinity, but the minimum is here, right? So that's where the cost function is at its minimum. Right. So any question in the cost function and the graph that I showed? Is it boring, or shall I skip this? I can skip this and go to the later ones. It's okay? Okay. Your question?
The point we find out from the earlier graph, these mean square error.
These points are mean square errors.
All of them, and we find the minimum.
Yeah. The mean square error, this j is a function, right? So for every x and y value, so if we have x and y in somewhere, we can plot a function, right? So this is the cost function. This is not your line, right? This is not your best line. This is the cost function. This is Napier model's function. This is the cost function. So we have to find the minimum value for that. So you guys, so to find the minimum cost, right? You guys have to adjust the weights of your model to some values and find it out, right? But the problem in that is, say if you have thousands and millions of data, right? You have millions of data. So you have millions of features as well. So how do you, efficiently find the cost at its minimum? You have to change the weight for every input value, and you have to find all values and find that one value is at its minimum, right? But we can't do it for larger data sets. We have to find a smart way to get the minimum point, right? So I don't know if you know that you can draw a line perpendicular to a curve, right? So don't note that. So if we draw a line perpendicular, right, make an angle, right? If we draw a line, we can get the m of that line, right? The increment, the m of that line. So if we draw a line at this point, what would the m be? If we draw a line perpendicular to the minimum one, what would the m be? 0. 0, right? So if we could find the perpendicular line to this curve and find the 0th value for m, so we can tell that this is our minimum value, right? So that's what the gradient descent algorithm does. To find the perpendicular line, you have to do the derivatives, right? At any point, you get so at any point when you get the derivatives, you get the m of that line, right? So if the derivative is 0, we can say that we have come to minimum. Right? Any questions in that? Do I need to explain that again, or is it clear? If anyone needs to explain it again, I can do it. So gradient descent is the first order optimization algorithm. Don't think about it. We take the partial derivatives of the cost function at each step. Don't think about that as well. So what we need to do is we find the local. Okay, local minimum is another thing. I'll try to explain the local minimum in the later slides if we have time. So to find the minimum, so can someone tell me what this graph is? Is it a two-dimensional one or a three-dimensional? So what are the three dimensions? X, Y, and Z. So I say that this is 4 dimensions. No, it's not 4 dimensions, it's 3 dimensions. Right? The third dimension is not shown in values, but in color, right? So if the color goes to dark red, it's a specific height, right? So the height is at its maximum is the dark red color, and the minimum value is at the dark blue color. So the gradient descent algorithm, what it does is, in our cost function, for every point in our cost function, it finds the gradient, right? You say C is 0. So if you do a line here, is the m positive or negative? Mx plus C. So if we get a positive m, we get a line going like this, right? If we get a negative m, the line is this way. M is 0 is this, m is infinity is this, m is positive is this, negative is this, right? So if we get an m negative, we can say that the next steps going to be negative and it's going to come to 0, right? If the negative decreases, we know that it's going to come to a 0, right? So negative, 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 and 0.